Okay, here we go. So this is below sea level. First Tuesday of every month. Um, Generally, we do stuff about systems programming. We're located here in New Orleans, but uh, we're starting to try to take remote speakers where we can. So, Dan's our first remote speaker. So, thank you for taking this chance on us with VDO.Ninja. But yeah, today we're going to have Dan talk about file systems and WASM and a bunch of interesting things about POSIX. And we don't have a talk coming up for next month yet, so we got to fill that. So if anyone's interested in that, let us know. After that, we have Austin talking about reverse engineering some Sega Genesis games, which should be cool. And then the calendar is free after that. So if anyone has anything they want to talk about, anything they want to learn, come talk to me or talk to Aaron. Reach out to us in the New Orleans Dev Slack or on Twitter. But yeah, so let's give it over to Dan. So you want to get started?
Yeah, for sure. Cool. So let me just get this into full screen here. Yeah, cool. Well, thanks a lot, Ben. Thanks for having me. I hope everyone can hear me okay. Feel free to just yell at me if you can't, and I'll try to adjust stuff. But yeah, so my name's Dan Phillips, and I'm going to be talking about file systems everywhere. And I'll just kind of kick it off with a little bit about me. So I'm an engineer and the WASM lead at a startup called Loophole Labs. We specifically work on infrastructure primitives, and I work on a lot of the WASM stuff. I also run the WASM Chicago group. And actually, just so everyone is aware, Ben, our illustrious host, is going to be speaking at our group in 2 weeks, so on the 15th of August, and that'll also be streamed. It'll also be virtual. So we kind of orchestrated this meetup exchange when we met up at a conference earlier this year, and it was his idea. So thanks a lot for having me.
Sure.
On socials, I'm D_Phila, and I usually just tweet about WebAssembly and related stuff in the industry. So just to get right to it, so to talk about file systems. So specifically in WebAssembly, what do we do about file systems, right? Applications need them, and WebAssembly alone does not have them. And I do apologize, Ben, some of these slides are recycled from some of my earlier talks, so don't hold that against me. Okay. So if we think about file systems, we can think about them from being used kind of on bare metal to VMs to containers. And what about WebAssembly? You can't really talk about file systems in their current use or in their use for the last 50 years without talking about POSIX, right? Which is Portable Operating System Interface. What is POSIX, right? POSIX defines the interface. You can think of it as a sort of combination of libc functions and syscalls. And actually where they draw the line between the two sometimes is a little bit murky, which I'll get into later. POSIX also kind of specifically implies that there's a virtual file system in the Linux kernel, which I'll also talk about here briefly. There's basically the point of the VFS in Linux is to provide an abstraction layer between user space and the underlying file storage mechanism, which could be networked, block devices, etc. Right? Yeah. So to sort of see this from a traditional Linux perspective, a virtual file system, which are ubiquitous in, as far as I know, all kernel implementations, is basically like this gray box, right? And this gray box, you can see, encapsulates these different type of file systems, of actual underlying file systems, right? Block-based file systems, network FS, pseudo file systems. You've got Fuse here, which we'll talk about. But really the point is that you have a standard interface, which is defined by POSIX for interacting with files, regardless of the underlying technology for storing information. So in WebAssembly, what are the current approaches for dealing with files, right? Dealing with a file system. Databases need them, lots of things need them. One of the things that people think about first is WASI, right? Which is the WebAssembly System Interface. So WASI can provide scoped access to host file system resources, right? Which is kind of a different take on sort of the Unix perspective of roles and permissions. There's a specific interface that must be compiled when you are writing WASI, when you're writing WebAssembly for WASI, right? And that's specifically WASI libc, right? So compilers will take your system level code, it will compile it and translate the system calls into the WASI libc calls, right? And this is a deeper sort of topic that can be explored more, probably in an entire talk, which is that WASI libc is also undergoing some changes with the transition from WASI Preview 1 to Preview 2 and eventually Preview 3. Another approach for using a file system in just pure WASM and core WASM is mscripton, which is sort of the OG approach, right? This is the first approach. This gives you a sort of web first, it's VFS on top of JavaScript bindings, right? That can be backed by underlying storage like IndexedDB or local storage. And basically what this does is sort of shim out the syscalls and the libc functions to actual JavaScript calls. This is based on unadapted muscle libc, if anyone's worked with that flavor of libc. And then you've got a newer approach, which is a WASI-specific VFS, right? Which is an in-memory WASM embedded read-only virtual file system, which hooks into the WASI libc calls and allows you to not have to use the underlying host file system. So right now, also this is only read-only, so there's no writing that is allowed, as far as I know, although that might be included soon. And actually, it was kind of an inspiration for sort of what I'm going to talk about here. So these are the current approaches, and one thing that we were sort of kicking around in the last year or so at Loophole was, why don't we take this one step further, right? So if we think about these abstractions that we're used to at a systems level, right? We have sort of user space and kernel space. We have standard library, standard C library calls, libcs as they're known, syscalls. You've got context switching. So if we question these abstractions all the way down, what can we sort of come up with? So one of the ideas that we came up with was, instead of having to rely on something like WASI specifically, or instead of having to use a specific tool chain like mscripton, what if we just had it all in WebAssembly, right? So a WASM libc and a WASM first file system. So many programs in the world today rely on a libc interface for file I/O, right? This way we could kind of have freedom from underlying hosts, right? You wouldn't have to re-implement at the runtime level. And then why wouldn't we do this? Well, writing a file system is not a trivial thing to do. It's a lot to reinvent, and there's a lot of things that just won't be possible in a WebAssembly first environment. So we'll kind of talk through sort of how this worked. Okay, so to start off, a libc is needed, right? But which one? So libc is really just needed to satisfy the interfaces, right? So we need to provide the interfaces just like you would have if you were on an operating system that had a standard C library that a C program or some sort of underlying program would expect to be there, right? And what we don't want to do is port abstractions from systems with different constraints, right? So we can kind of ignore these Linux conventions and only take what we need. Okay, so we want to start with very simple file system, right? Something that's very, very plain and something that is as universal as possible, right? Things like basic syscalls, providing structure, reading and writing, and permissions. And then you've got to wonder, is this just going to be another fuse, right? Fuse is the file system in user space, right? Which has taken a lot of heat over the years for performance implications. But like I was saying, there's really no reason to borrow the same constraints from previous paradigms. So thinking about things in terms of kernel and user space, maybe we don't really even have to think in those terms. And I'll kind of get more to that later when we talk about performance. So, and the idea here too is that it's virtual only by virtue of being in a WASM environment, right? It's literally just what we would call syscalls on top of some kind of storage layer that is within the limits of a WASM module under a libc, right? And one of the last goals is that the fewer abstractions that leak, the better. Cool. So one of the big things that people at Dylib and also at Loophole and a lot of people in the WebAssembly space know is that WebAssembly is a great fit for serverless functions, right? So if we have this great fit with WebAssembly, we still have to deal with the storage layer. And so maybe a slim WASM first file system could be a good fit in some situations. Cool. So this is a QR code that goes to scale.sh, which is our WebAssembly function runtime that we worked on at Loophole. And then these two projects are sort of what I'm going to talk about and do a short demo. So I'm going to get out of this. And these are both very work in progress. So the first one is WASM VFS, right? So this is the underlying virtual file system, which is a series of abstractions that create the interfaces that you would expect in file system related syscalls, right? So if you look at the README, you can see that these are the functions, these are the syscalls, even though they're not syscalls in the traditional sense, that are provided by this file system. So descriptor management, reading and writing, permissions, status and position, all these things, and then you get to some points where we have some, we should probably have asterisks actually to talk about why some of these things may be possible and may kind of not work in the way that you might expect them, right? Yeah, and so this, used in conjunction with WASM libc, which WASM libc is basically just generic libc bindings that are written in Rust with a C representation that allow, when compiled with WASM VFS, allow you to take something that you would expect to have on something like a GNU libc operating system and then just work, right? If you can trick the compiler into thinking that it's not doing it for WASI or for WebAssembly, right? You'll notice the caveat here. This is very, very experimental still. So if you do want to play around with this, then do so at your own peril. But we'll be moving this more into more serious beta testing and then hopefully production uses soon. So with this in mind, we'll take a quick look at a scale function, right?
Do you mind going to light mode if you could on the code?
On the code, actually, this, I think it's hard coded in, like, I mean, this is like a, I don't think I have light mode here because it's just a Vim theme. I'm sorry. Can you guys not see this?
It's a little tricky. You can't just do like set background equals light or something.
I don't know how to do that off the top of my head. But you know what I can do is I can just show you in the docs.
Yeah, that'd be great. Thank you.
Yeah, let's do that. So, okay, cool. So let me find a function. Yeah, okay. Okay, so right, so a scale function basically is just a simple function that's written in either Go, JavaScript, or Rust, and it is set up for you to really not have to worry about WebAssembly at all, besides the build step, right? And one of the things that can be useful in this is that it just takes like a context object, right? You can do stuff to it, then you can return that context object. And that is what happens inside the guest side of the WebAssembly module, right? Specifically, we kind of have this working for HTTP functions. And in Scale itself, we have because it's written in Go and it uses Y0 as our function run, as our WebAssembly runtime, we have an HTTP server right out of the box. So what we can do is and can you guys see this, or is this too dark also?
It's pretty dark, but don't worry about it.
Okay, let's see.
You could definitely make it bigger though. That might help.
All right.
Yeah, thanks.
Okay. All right, so all right, so this is our scale function that we have. And right now you can see that we're using Rust's standard file system library. And usually in WebAssembly, this wouldn't do anything for you because these functions wouldn't even get compiled, right? They would just throw an exception if you tried to use them. In fact, they'd probably throw a panic. And so one of the ways that using this VFS makes this easy is that just like you would compiling for a native app, you just include the library, and then in your scale function, which is here, right? This takes in this context object, right? Which in this case is an HTTP request. It's basically like an HTTP request struct. I know I said no leaky abstractions, but of course, this is still a work in progress. So you initialize the globals here, right? And then you have a string, which we can say is a file name. You can open the file just like you would on a native platform. You can have something to write in the file, turn that string into bytes, right? Write those bytes to the file, okay? Read those bytes from the file, okay? And then return the response, right? With the file itself, right? And then close happens in Rust. This happens, it's implied when the function exits, right? So to do that, we can see that if we were to just go here, then you have the file being returned, which this is just to sort of take a couple steps back. This is a WebAssembly guest function that is interacting with a file and then returning a file to the end user, right? So this file is totally done in a virtual ephemeral space, right? This is a very highly idealized example, but this is just kind of a little taste of what that, how this could work. So, yeah, scale.sh too. This has more examples and more docs and stuff. And as I mentioned to Ben earlier, it's very different from Xism, and in terms of things that we do. And so, but of course,
Popular.
they're both extremely good products. You guys should try them both. So, I don't know if Shiv is watching, but that's cool. Okay, let's see. All right, so to carry on here, let me get back into this. Okay, so what about actual persistence, right? Like a database or something that's built on top of a file system isn't that great unless you have persistence. So there are a couple different options here that we can do, and this kind of gets into more of the sort of title of the talk, right? So if we think about what a VFS does in the Linux kernel, right, it provides a common abstraction above all types of actual storage, right? There's no reason that a WebAssembly, dare I say, component could do the same thing above above the same variety of persistence options, right? So we're going to kind of walk through what that could look like. So one of the possibilities is that module load state on instantiation from a centralized source of truth. Even another VFS, another world per the component model, which I'll get into towards the end, another WASM module from the host, from a host function call, or from another file system. Possibility two is that you have one stateful WASI module, right, that talks to the underlying host system, right? And that can be exposed via a resource handle to a WASM-only application that has module instances that signal on shutdown that either you flush to or you can flush to that WASI module to sort of deal with the persistence action at different times, much like what happens in the Linux kernel with a Linux VFS. This is an interesting idea because there is some concern by in the community about what WASI can allow for, and if that is kind of exactly in line with the sort of isolation and sandboxing that WASM is now kind of famous for. And this kind of takes that away, where it says, okay, we only have one component, one module that is a WASI module. Everything else is just pure WASM, right? No access, no knowledge of the outside world inside the WASM module itself. Yeah, like the kernel implemented VFS. Okay, so how ephemeral does the stateful component need to be, right? You know, big words make for good conference titles. So that was kind of the part of this talk previously. So you know, the stateful layer could span several related or recurring application instances. That's a little bit hand wavy because if anyone has, in fact, I'm almost positive that you guys have a dilib, even in the name dilib, like the dealing with module linking in WebAssembly, dynamically or statically, is still a developing area, and so how that could work well within a runtime or orchestration environment is still sort of a developing challenge. But there are some really promising ways forward there. So more exploration there is definitely needed. The future, right? So here is where I'm going to talk about, you know, why isn't there a good reason to do this? Well, you know, if we had, if we can think about in-memory user space sort of programs like databases, things like Redis, Memcache, all these things, a lot of these things could be easily used, not easily, but with some upfront work, used in WASM first components, right? You know, virtual file systems already help to standardize storage interaction in kernel implementations. Why not in this paradigm, right? And then, you know, linking to a persistent storage layer can then be pushed to the problem space of distributed computing if the path is pursued. And one of the interesting things too about the VFS layer in the Linux kernel is that, like, that's across the context switching boundary, right, of system calls. So the kind of interesting thing there, at least to me, is that people are very concerned with syscalls because of their overhead, right? And the kind of cool thing with this paradigm of using a virtual file system in a WebAssembly first environment is that it's possible then to have file system related syscalls that are faster than native calls by, like, I'm not actually sure how much because we haven't done rigorous testing here, but the ability to call a function from another module is trivial compared to the sort of context switching that happens in the Linux kernel, right? So that's interesting. There are more challenges though, right? So there are several libcs, right? And you know, there's several flavors of the C standard library across platforms. And these wrap even further variety of syscalls, right? And I'm just talking Linux here too. You know, I mean, Windows has very similar things in certain ways, but even just in Linux. And these interact with vast types of real, virtual, and non-WASM file systems on even more types of platforms, right? So how do we deal with this? Well, one of the ways is with tooling, right? And one thing that we've been working on, and there's some other great groups out there like Dilib too, some awesome observability and tooling projects that kind of give you this insight into a WASM module that can kind of work like strace, right? So you've got, like, you want to know what syscalls would be executed in this WebAssembly function if it were to have been compiled to a native platform of your choosing. So that seems kind of backwards, but the reason we need that is we need to see what kind of interfaces we need to build to access the VFS like we would on a native platform. So this is kind of an interesting idea where you could look at a WASM module, you could figure out what system calls would be made, and then you could build those interfaces on top. You could build those interfaces, take that virtualization slice of the libc definitions, and put that on top of the VFS. right? And then you have this sort of self-contained system, at least when it comes to file system related syscalls. And that's cool too, because space is at a premium in WebAssembly environments, regardless of what kind of work you're doing with them. And so you would only need to implement what is needed for a given module, right? And so we're still exploring some ideas here, but there's some cool ways forward. And then this allows for something called virtual platform layering, which is a term that I kind of am quoting from Luke Wagner, who's one of the creators of WebAssembly. And so, when you contrast this with POSIX syscall kernel user space abstractions, you could really just use what is needed for a specific instance of a module, and then nothing more, right? And that kind of dovetails nicely into the sort of discussion of the WebAssembly component model, right? So you've got virtualization layers, right? Which is where, let's say you need a file system, that could be one layer of virtualization. And the sort of what this kind of brings to mind is sort of how dependency trees work in container images, right? So certain layers can be reused. They can be updated only for that specific layer. And there's not a great reason that WebAssembly can't work in the same way, especially in this sort of component-based future that we're looking at. And then with the component model too, things like resource and handle types, this could mean that the only glue code that is needed is a libc interface. Resource and handle types are where you can just get a handle to an underlying resource and have basically direct access to that instead of having to serialize it across the boundary. This could be a huge boon for performance. Like if it kind of makes you think of things like Cap and Proto, but even faster, right? Because it's both sides of what would otherwise be serializing and deserializing. So these resources are then directly usable, right? So I said minimal syscall cost, and likely better than native, which is kind of an interesting concept. So tooling for this, for virtualization, for developing the interfaces and the file system could make for a really promising future. And in fact, I'm just going to stop here for 1 second. And there is this great new project by the Bytecode Alliance that does this very thing, specifically for WASI, but it's called WASI-Virt, and it works on virtualizing components that can be used with WASI Preview 2 with some of the component model composition tools. So this is a very, very new project, and they are doing some cool work with file systems. They actually use the WASI VFS here, the read-only WASI VFS that hooks into the WASI libc calls, and they're working on some of these other layers as well. So definitely check that out. But yeah, so to finish out here, what this then allows you to do, like I showed in the example, is to write file system code, use a file system for all file system things, possibly faster than what's possible on native platforms, in a relatively constrained environment, but maybe not that constrained in the future when we have a better story for module linking, and especially via the component model. So what this allows us to do is think of WebAssembly as an implementation detail, right? Which kind of gives you this idea of you could have file systems everywhere, right? They could be isomorphic. They could be in the browser, on the server, in an embedded device, in your phone. It doesn't matter because it could be on the edge. It doesn't matter because what matters is what they're there to provide to the specific functionality of a given module. And then everything else can be figured out at the distributed computing layer. So kind of an interesting thought, and that was kind of the sort of what I was trying to provoke with the title of this talk. So yeah, cool. Thank you. That is my talk. Went a little fast, I think, about 30 minutes. I'd like to say thank you to Ben and the group. Thanks for having me. It's really fun.
Yeah, I've got a bunch of questions if you have time.
Yes. Oh, yeah. I got plenty of time. Yeah, I got plenty of time. This is my contact info if you guys want to, if you need anything. And yeah, I got plenty of time. Let me
Okay.
stop sharing
Yeah,
my screen.
we'll ask some questions, and we're like kind of lagged, so maybe the internet will ask some too. But you guys want to go first, or
Yeah, I have a quick question about
can you hear him? Okay.
Yes. Yes.
so I'm curious about the one of the fundamental assumptions is that like when sync returns, everything's persisted to disk. And
Yeah.
if you're realizing that, like that breaks that assumption for a lot of things. Like you sync and return, and like your data isn't actually like is this like what are the implications of that? And like does that prevent you from using trying to run Redis or Postgres or something that does rely on that?
Yeah. Yeah, for sure. I mean, so I'm glad you brought that up actually, because that specifically, if I share my screen one more time here, that specifically is sync. Yeah. So specifically sync, right? Sync and return, like these things, like these are the bigger challenges when it comes to sort of like how the persistence layer is actually going to work, right? So let's say you wanted to mount this on some kind of block device and it was with WASI. Well, that's actually not that big of a problem, right? Like you could even like have it write to like as close to the device as possible. There's people who are doing this with Whammer, which is like the WebAssembly micro runtime on embedded devices, and so in theory, it could work exactly as it would on a native platform. But one thing that we're playing around with is like configurability with flushing and and how that would look or work. But you're absolutely right. That's very much still an open question. Yeah.
Okay.
I had a quick question about the when I didn't want to stop you when you were doing the demo where you pulled down the file from the web server. Was that like an embedded file in the actual WASM, or was that reading off disk?
Yeah. Yes.
Oh, okay. So it was like it was an embedded virtual file system.
Exactly. Yeah. Yeah. Exactly. So yeah. So there was no actual writing to a disk, like to disk anywhere, but what was written to the response was the same bytes that a virtual file system would return from the Linux kernel. So it's the same thing. It's basically like we created a file in memory and then returned it.
Where where does the stuff live in the WASM module? Where does the data live? It lives like in the data section or something?
Yeah, exactly. So like we've played around with a few different things, but uh like, well, you mean the actual file data? The
Yeah.
file data just lives in the memory space, in the linear memory.
Yeah. Okay. So it's but in the WASM file, it's like in the data section probably.
Yeah.
Right?
Yeah.
And it gets
Yeah.
loaded in the memory. Okay.
Yeah. Well, it doesn't get loaded into memory, although that is an option that we're planning to provide with the CLI, where you
Right.
could basically mount your local like a local directory, and you could basically mmap it into the WASM memory specifically.
Okay.
Yeah.
Curious if you've benchmarked that against like a RAM disk or something.
No, we have not. No. Yeah. But we definitely should. Yeah.
Could you explain WASM-virt or WASI-virt again? Like, that's the first I've seen that, but is that basically like the realization of Luke's talk about virtualized? It's kind of like little slices of capabilities or something.
Yeah. So I'm not an expert in this specific project, but the Bytecode Alliance just like kind of made it public, and
Cool.
it's very new. But yeah, it's basically virtualization layers that are like virtual components for WASI specifically, right? And so I don't know much about how they. I know that the guy who created the WASI VFS library, which is this read-only VFS that hooks into WASI libc, he reached out to the Bytecode Alliance and was like, "Hey, this virtualization idea would work really well with this VFS that I built." And so they're basically taking his project and creating, like, when you create a virtual world that is a file system, it is the WASI VFS, the read-only file system. How they're going to approach other things like network entities and like clocks and stuff, I'm not actually sure yet. So I'm actually very curious to learn also. I literally just learned about this last week at the community call for the Bytecode Alliance. So yeah, I mean, Luke Wagner's talk on sort of the 4 pillars of the component model from last year's WASM days is kind of where some of these ideas around virtualization kind of came from that I was mentioning. But there's a bunch more that I didn't mention that sort of can feed into how using something like a virtual file system in a WebAssembly first environment could be a really cool way to do file system related things in the future. And I don't know, we'll see how things work out in that regard.
Yeah, I've used WASI VFS for, I think, like Python.
Yeah.
One of the implementations of Python that people were doing, which I think was can't remember who put it together, but they used WASI VFS to like actually hold all the site modules and all that stuff.
Yeah, I think that might have been the VMware people.
Yeah, the VMware one, right?
Yeah. Actually, I've talked with Yuta Saito, the creator of it, and he's the lead maintainer of the Ruby WASM build also. And so he originally wrote that so that he could demo Ruby WASM, like see Ruby's WASM build like online and stuff. And so yeah, it's super cool. I think so. Like one of the main reasons that we kind of started working on this was that we thought it would be cool to like kind of have a similar thing without the WASI dependency specifically. And there's positives and negatives to that approach, because what we are going to do is not just support generic libc bindings, but also WASI libc. So you could use like the virtual file system underneath like what is effectively a GNU libc, or what is effectively or what is like WASI libc shins. So, but that's also down the road too. So.
That'd be cool, because there's all these like old horrible GIS file formats that, like, technically they have